Have you ever pondered over the state of our planet's climate and what it implies for future generations? The current climate crisis is a stark reality we cannot ignore. In 2023, we witnessed the warmest year on record, with temperature highs shattering records across the globe. This heat wave brought with it a drastic reduction in Antarctic sea ice and pushed global ocean temperatures to unprecedented levels. While factors like the El Niño phenomenon might cause a slight dip in average temperatures in the coming years, don't let this fool you. The long-term trend is clear: our planet is warming, and it's happening at an accelerating pace. We're on a trajectory that could see our world changing in ways we can't fully predict or prepare for. As the climate continues to change, an increasingly debated topic among climate scientists is equilibrium climate sensitivity, or ECS. So what exactly is equilibrium climate sensitivity and why is it causing such a stir? Let's dive right in. In the simplest terms, equilibrium climate sensitivity, or ECS, is a measure used by scientists to estimate the impact of a doubling of atmospheric CO2 levels on global temperatures. It's a bit like a climate thermometer, giving us an idea of how much hotter our planet could get if we continue to pump CO2 into the atmosphere at the same rate. But here's where the concern creeps in. Recent climate models are suggesting that the ECS might be higher than we previously thought. This means that global warming might be set to accelerate at a pace faster than we'd anticipated. The year 2023 stood out as the hottest on record, breaking temperature records in various parts of the world, drastically reducing Antarctic sea ice, and pushing global ocean temperatures to new highs. Despite the possibility of a slight dip in average temperatures in the coming years due to factors like the El Niño phenomenon, the long-term trend points to continued accelerated warming. Climate models forecasting a higher ECS are under scrutiny, primarily because their predictions are considered incompatible with historical data. These models, often referred to as hot models, suggest that our planet could heat up more than previously predicted if CO2 emissions continue to rise. This could put the lives of millions of people at risk, especially in densely populated equatorial regions, which would be the first and hardest hit by climate change. These hot models are raising alarm bells, suggesting that if CO2 emissions continue to rise, the planet could warm more than previously predicted. It's a sobering thought, isn't it? But it's also a call to action. We need to better understand these models, and most importantly, we need to take decisive action now to mitigate the potential impacts of climate change. But these hot models are not without controversy. High ECS climate models have come under intense scrutiny, primarily because their predictions seem incompatible with historical data. These models suggest that if CO2 emissions continue to rise, our planet could warm more than previously expected. This projection raises the stakes significantly, threatening the lives of millions, especially in densely populated equatorial regions, which are likely to be the first and most severely affected by climate change. The controversy intensifies when we consider the role of cloud modeling in climate studies. Clouds are a complex variable that play a significant role in ECS predictions. Some of the latest and hottest models feature more sophisticated ways of simulating cloud behavior, which could explain their higher climate sensitivity forecasts. But here's the rub: we lack direct historical data on cloud behavior from millions of years ago. This gap in our understanding raises doubts about the accuracy of these models. You see, clouds are tricky. They can both cool the planet by reflecting sunlight back into space and warm it by trapping heat. The balance between these two effects is subtle and can shift with changes in cloud type, altitude, and location. Moreover, clouds respond to and influence other aspects of the climate system in complex ways, making them a significant wildcard in climate modeling. Despite our advances in satellite technology and supercomputing, simulating the behavior of clouds accurately on a global scale remains a formidable challenge. Scientists are continually improving their models and methods, but the truth is, we still have a lot to learn about how clouds will respond to and affect future warming. So, where does this leave us? Well, the uncertainty surrounding ECS and cloud modeling underscores the complexity of our climate system and the challenges we face in predicting its future. But one thing is clear: we can't afford to wait until all the scientific uncertainties are resolved. In the face of this uncertainty, the need for immediate and decisive action against climate change becomes even more critical. We must confront the climate crisis head-on, using all the tools at our disposal. The time for debate is over. The time for action is now. So, given the potential risks, what can we do? We stand on the precipice of a significant climate crisis, teetering on the edge of irreversible damage. It's clear that the time for action is not tomorrow, not in an hour, but now. The question is, what actions can we take to combat this looming threat? One of the most impactful strategies is implementing a global price for carbon emissions. By attributing a cost to the carbon we emit, we can create a financial incentive for industries and individuals alike to reduce their carbon footprint. This is not just about punishment, but about creating a system where sustainable practices are the most economically viable option. Next, we need to push for the expansion of renewable energy. Solar, wind, hydroelectric. These are not technologies of the future, but technologies of today that we need to embrace fully. It's not enough to just supplement our energy needs with renewables. They need to become our primary sources of power. In the same vein, building new nuclear power plants is a strategy that warrants serious consideration. While nuclear energy has its critics, there's no denying that it offers a low-emission energy source that can help us transition away from fossil fuels. Additionally, we must invest in the development of carbon dioxide removal technologies. These technologies, which strip CO2 from the atmosphere, present a tangible way to reverse some of the damage we've already inflicted on our planet. But none of these solutions can exist in isolation. They need to form part of a comprehensive global approach to tackling climate change, one that involves governments, corporations, communities, and individuals all playing their part. The debate over ECS is not just academic, it's a wake-up call to the urgency with which we need to address climate change. The window of opportunity to avoid its worst impacts is closing fast, and inaction or hesitation could have irreversible consequences for our planet's climate and, by extension, for humanity's survival and well-being. We've been given a warning. Now it's up to us to heed it.